Alright everyone, so Alright everyone, so welcome to the channel. Again, I'm just explaining some basic stuff, and I decided to explain Malloc, which, let me just grab this here, put it like this. Okay, cool. So basically Malloc is a C function that stands for memory allocation, which is pretty cool, very useful. Well, what exactly does this mean? Well, basically it means that we are going to go into our memory. Let's say this is our memory, and we will allocate, we will separate a space in this memory for us to do something. And this is what Malloc does. It gets this piece and say, okay, give me like X amount of memory for me to work with. And then how exactly this works? Basically, Malloc will call the heap manager. The heap manager. And the heap manager is basically a manager that will deal with the heap memory. And if you don't know, we have two kinds. Oh my gosh, we have two types of memory. Let's say this is our memory. Okay, we have the heap and we have the stack. The stack memory is where we put our local variables, like int I equals to 0. This is going to be on the stack, or I don't know, printf something. This will what we put here will be on the stack as well. But the heap is different. The heap will deal with dynamic allocated memory. So if we say we want a string, okay, so an array of characters, let's say hello, right? These are different characters. We have HALLO. This is a string of characters, and sometimes we want to get the string and do something with it, and sometimes, let's say, we want to copy it, or we want to do some operation that we need to allocate some space in the heap memory to work with this string, for example. Then we use Malloc, and then we'll say Malloc, please gives us like X amount of space in the heap, because we are going to do something here. And this is what Malloc does. So coming here to the code, how can we see that actually working? So let's just use the function string duplicate as a good example for us to understand what's going on. So we are going to create our own function. So it is a char ft string dup, and it will take a string as a parameter. You probably know what pointers are, but if you don't, I am planning on making a video. If you don't want to watch my video, go, I don't know, YouTube yourself. So basically what we're going to do is we will return a string that is the exact copy of the string we are going to get. So we'll do char dest, which stands for destination. Now we want dest to be the same size of str, but how can we do it? Well, when we do Malloc, we say the dest is equals to Malloc size of char. This is just a good practice. Usually we can remove it or just put 4, but it's a good practice because in different operational systems the char might not be 4 bytes. It might be, I don't know, maybe 8 or maybe 1. I mean, char is 1 byte, but in another operating system it can be another number. So since we want to do a program that is useful on every single OS, we will always put size of char times, so what we need to multiplicate that by. Well, if we want to get some space for the string hello, well, at least we'll need to have 5 characters on it, or at least this, since each character is a byte, this would be 5 bytes, but let's say it is an array of ints, then it would change. In our case here, we want the total length of the source, right? So we would do string len str. However, no string can just end bluntly without a null terminator. So we need to alloc also one more space for us to put the null terminator. So we do +1 right here. And then we put a checker, which is very important, that if this malloc for any reason fails, we will return no, because the malloc failed, destination will be basically anything, so it's gonna be no. And then we just do a basic while loop, for example, while str of I exists, then dest I is gonna be equals to str of I plus plus. And then we just need to remember that I is equals to 0, and then we return the destination. Pretty cool. So let's see this working on our main. So we have char str is equals to hello, no, yeah, just hello. And then we're going to printf as str, return 0 right here. So if we compile, or hold up, yeah, compile memory allocation, we have here hello. And let's just say that original string is equals to hello. Then we compile again, right? The original string is equals to hello. Let's say we want to duplicate this string. Well, we would do char dest is equals to ft string dup of str, and then we're going to printf this is the copy and that's here. We already returning no. We compile again, and as you can see, we have an exact copy is equals, yeah. As you can see, we have an exact copy of the string because we allocated the space necessary for us to print hello and for us to put the null terminator right here. However, something to keep in mind with malloc is that we are allocating some memory. It means, let's just get our drawing here again. It means we have some space on the heap right here. However, we cannot just keep this space forever, because differently from things in the stack, where after our main loop, so if our main loop, which is our main function, ends, everything in the stack is clear. But this does not happen in the main function. If we finish our program and we didn't, and the memory we allocated is still there, we didn't free it in any kind of way, this memory is going to still be on the heap. So in order to deal with this problem, we need to free it afterwards. So we will free dest, and you will see nothing differently on the output. However, a lot of things happen behind the scenes. So if I were to comment this, and I will use valgrind, which is a tool that you can use to see what is happening with your memory, and do a.out. Oh, I need to compile again. A.out, valgrind, A.out. Then we see something. We see on the heap summary, so the heap is giving us a log of what is going on. In use at exit 6 bytes in one block, so pretty obvious. We have hello, which is 5 bytes plus the null terminator, so 6 bytes in one block. We have 2 allocations and 1 free. Wait, 2 allocations? Yes, because this is kind of an allocation, but basically we just have 1 free that the system is doing by itself, but we need to do the other because we just created a function and we need to free this basically. So we definitely lost 6 bytes in one block. So, oh, by the way, this definitely lost, indirectly lost, possibly lost are all different things, and it's pretty a hassle to search them, but sometimes you just need to do it. If I compile this again and do a.out with Valgrind, then we see all heap blocks were freed. No leaks are possible. And this is pretty easy to deal with when we are dealing with small programs, but when it gets to a point where you have 3,000 lines of code and 500 mallocs, it is important to keep in mind that every single time that you allocate memory, we need to free this memory before the program ends, or else this memory is going to be on the heap, and this will be a memory leak. And this is a pretty huge issue if you are basically into tech in general, but if you work with security, for example, having a leak in the memory is not the thing that we really want to deal with. Now, we are just using a basic example right here, but we can also do a bigger example, but it is simple as well. So we can just ignore this. Well, yeah, we don't need to erase it, but we would ignore it, for example. So we'll have 3 strings, char1 equals sozo, sozo space, char str2 equals no, char str3 equals to fleeting /n. Okay, so here we have 3 strings, sozo no freeing, str1, 2, and 3, and we want all of them to become a single string per se. So we follow the same logic. Char dest equals to malloc, again size of char times. Now it will be a little bit time consuming, but it is the string length of str1 plus the string length of the str2 plus the length of the str3 plus the last character that's gonna be our no byte. So it would be 8 plus 4 plus 9 plus 1. Again, we say that if malloc doesn't work, we will return 1 in this case. Here we don't need to free anything because the allocation couldn't work, so there's nothing on the heap, so there's nothing we need to free. Now we do basically we can do string copy, where we'll put our destination will be dest and it will be str1. Then we do string cat str2 dest str2, and then string cat again of dest and str3. And then we cannot forget that the dest, oh no, in this case we don't need to do it. And now we can print f in a single string %s/n, and we put dest return 0. So we compile it, and in a single string we have sozo no freedom. So yeah, basically that's it. There is not much secret, and we can also allocate memory for arrays. We can like char pointer matrix and then allocate some memory for it. But in this case, we would need, for example, malloc size of char pointer times, I don't know, whatever you want here. Let's say, I don't know, you want 50 bytes plus 1. And then again, if matrix, we return no again, 1 in this case because they are in the main function, or an int we can do int I equals 0. No, we can have int I that will be allocated in this case. It will be size of int, which in this case is 4 times, I don't know, let's say 5. In this case we don't need the +1. And then if I don't never forget this, we return 1, for example. But this is basically the basics of Malloc. Study, program, do things by yourself. If you want to, I don't know, do a better string up than me or something, it's up to you. Bye.